blast off with me on a journey to the very beginning of our solar system. Imagine traveling back in time, over 4.6 billion years ago, to witness the birth of our cosmic neighborhood. It's a tale of chaos, collisions, and cosmic creativity. Our solar system formed about 4.6 billion years ago from a dense cloud of interstellar gas and dust. This cloud, known as the solar nebula, was a vast, swirling mass of particles and gases floating in the emptiness of space. This cloud collapsed, possibly triggered by the shockwave of a nearby supernova explosion. As it collapsed, it began to spin, forming a flat, rotating disk known as the solar nebula. The center of this disk grew increasingly hot and dense. At the center, gravity pulled more and more material in, until the pressure and temperature were high enough for nuclear fusion to begin. Hydrogen atoms fused into helium, releasing immense energy and giving birth to our sun, a new star in the galaxy. The sun, now a blazing ball of energy, gobbled up 99% of the available matter in the solar nebula. It became the dominant force in our young solar system, its gravity shaping the orbits of everything around it. Further out in the disk, particles of dust and gas began to stick together, clumping into larger and larger pieces. These clumps collided and merged, growing into planetesimals, the building blocks of planets. Over millions of years, these planetesimals continued to collide and merge, forming protoplanets. The asteroid belt, located between Mars and Jupiter, is a region filled with rocky debris. These are the leftover bits that never managed to form a planet, remnants of the early solar system's building process. Smaller pieces of debris became asteroids, comets, and meteoroids. Asteroids are rocky bodies, while comets are icy, and meteoroids are smaller fragments. These objects continue to orbit the Sun, occasionally crossing paths with planets. The closest planets to the Sun, Mercury, Venus, Earth, and Mars, are known as the terrestrial planets. They are rocky because only solid materials could withstand the intense heat of the early solar system. These planets have solid surfaces and are composed mainly of rock and metal. Further out, where conditions were cooler, gas and ice giants like Jupiter, Saturn, Uranus, and Neptune formed. These planets are composed mostly of hydrogen, helium, and other gases, with thick atmospheres and no solid surface. They also have rings and numerous moons. So there you have it. The amazing birth and structure of our solar system. From a swirling cloud of gas and dust to a complex system of planets, moons, asteroids, and comets, our solar system is a testament to the incredible processes that shape the universe. Keep looking up and marvel at the wonders of the cosmos. Welcome to Chapter 2, The Birth of the Sun. Let's zoom in on the heart of our solar system's formation, the creation of our sun. Imagine a dark, cold region of interstellar space filled with a cloud of gas and dust. This cloud, known as the solar nebula, was vast and diffuse, yet it held the seeds of something extraordinary. Approximately 4.6 billion years ago, a cataclysmic event, such as a nearby supernova explosion, sent shockwaves through the solar nebula. This disturbance caused the cloud to collapse under its own gravity. As the cloud contracted, it began to spin and flatten into a rotating disk. The material in the center of this disk grew increasingly hot and dense. In this swirling chaos, gravity worked its magic, pulling more and more material into the center. The pressure and temperature soared to unimaginable levels. When the conditions were just right, nuclear fusion ignited. Hydrogen atoms fused together to form helium, releasing a tremendous amount of energy. This powerful reaction gave birth to our sun, a new star blazing with light and heat. The sun, now a massive ball of energy, dominated the young solar system. It consumed 99% of the material in the solar nebula, leaving just a fraction for the formation of planets and other celestial objects. The immense gravitational pull of the sun shaped the orbits of everything around it, establishing the structure of our solar system. The birth of the sun was a defining moment, setting the stage for the formation of the planets and the intricate dance of celestial bodies that we observe today. As we gaze at the sun, we are looking at the engine that powers our solar system, a reminder of the incredible processes that govern the universe. So the next time you feel the warmth of the sun on your face, remember its cosmic origins and the journey that began over 4.6 billion years ago. Our sun is more than just a source of light and heat. It is a testament to the dynamic and ever-evolving nature of the cosmos. Stay tuned as we continue our exploration of the solar system and uncover more of the mysteries that lie beyond our home planet. Welcome to Chapter 3, Formation of the planets. With the birth of the Sun, the stage was set for the formation of the planets. The remaining material in the rotating disk around the young Sun began to coalesce, forming clumps of dust and gas. These clumps, or planetesimals, collided and merged, growing larger over time. In the inner regions of the disk, where temperatures were higher, rocky planets began to take shape. These terrestrial planets, including Mercury, Venus, Earth, and Mars, formed from heavier elements that could withstand the intense heat. The outer regions, where it was cooler, allowed for the formation of gas giants like Jupiter and Saturn, as well as ice giants like Uranus and Neptune. These planets accumulated vast amounts of hydrogen, helium, and other volatile compounds. As the planets grew, they began to clear their orbits of debris, shaping the solar system as we know it today. The gravitational interactions between these young planets also played a crucial role, influencing their positions and the overall structure of the solar system. The formation of the planets was a complex and dynamic process, marked by collisions, accretions, and migrations. Each planet's unique characteristics and position within the solar system are a testament to this intricate dance of celestial bodies. As we look at the planets today, we see the results of billions of years of evolution and change. From the rocky surfaces of Mars to the swirling storms of Jupiter, each planet tells a story of its own. Our journey through the solar system is just beginning, and there is still so much more to discover. Join us next time as we delve deeper into the mysteries of our cosmic neighborhood and uncover the secrets of the planets that share our solar system. Stay curious and keep exploring. Welcome to Chapter 4, the role of gravity. Gravity, the invisible force that governs the universe, played a pivotal role in shaping our solar system. From the moment the solar nebula began to collapse, gravity was at work, pulling matter together and initiating the formation of the Sun and planets. As the young Sun ignited, its immense gravitational pull began to influence the surrounding material. The Sun's gravity kept the protoplanetary disk in orbit, allowing for the gradual coalescence of dust and gas into planetesimals. These planetesimals, under the influence of their own gravitational forces, collided and merged to form the planets. Gravity didn't just help form the planets, it also determined their positions and orbits. The gravitational interactions between the young planets caused them to migrate, shift, and settle into their current paths around the Sun. This process, known as planetary migration, was crucial in shaping the architecture of our solar system. But gravity's influence extends beyond the planets themselves. It governs the orbits of moons, the paths of comets and asteroids, and even the structure of the Kuiper Belt and Oort cloud. The seemingly chaotic dance of celestial bodies is in fact a testament to the elegant and predictable nature of gravitational forces. One of the most intriguing aspects of gravity is its role in creating and maintaining the delicate balance of our solar system. The gravitational pull of Jupiter, the largest planet, acts as a shield, deflecting potentially hazardous comets and asteroids away from the inner planets. Meanwhile, the gravitational interactions between Earth and its moon stabilize our planet's axial tilt, contributing to the relatively stable climate that has allowed life to flourish. As we continue our exploration of the solar system, we must always remember the fundamental force that made it all possible. Gravity, the unseen architect of the cosmos, continues to shape and influence the universe in ways we are only beginning to understand. Join us next time as we delve into the mysteries of the outer solar system and explore the distant, icy realms that lie beyond Neptune. Stay curious and keep exploring. Welcome to Chapter 5, the Asteroid Belt and Beyond. As we venture further into our solar system, we encounter a fascinating region filled with rocky remnants from its formation, the asteroid belt. This vast expanse, located between the orbits of Mars and Jupiter, is home to millions of asteroids, ranging from tiny pebbles to massive bodies hundreds of kilometers across. But how did this cosmic debris field come to be? The story begins with the same protoplanetary disk from which the planets formed. In this region, the gravitational influence of nearby Jupiter prevented the material from coalescing into a full-fledged planet. Instead, the remnants of this thwarted planetary formation became what we now know as the asteroid belt. These asteroids are not just random space rocks, they hold valuable clues to the early solar system. Scientists study these ancient bodies to understand the conditions and processes that were present during the birth of our planetary neighborhood. Some asteroids even contain organic compounds, hinting at the potential for life's building blocks to be widespread throughout the cosmos. Beyond the asteroid belt lies the realm of the gas giants and their icy moons. Jupiter, with its immense gravitational pull, acts as a celestial gatekeeper, influencing the orbits of countless smaller objects. Its gravity helps to shape the paths of comets and asteroids, sending some hurtling towards the inner solar system while capturing others as moons, or sending them into distant, elongated orbits. Further still, we reach the Kuiper Belt, a distant region populated by icy bodies and dwarf planets, including the famous Pluto. This area is a treasure trove of primordial material, offering a glimpse into the solar system's outer reaches and the processes that shaped it. And even beyond the Kuiper Belt lies the mysterious Oort cloud, a vast spherical shell of icy objects that surrounds our solar system. It is thought to be the source of long-period comets that occasionally grace our skies, bringing with them ancient material from the farthest reaches of the sun's influence. The asteroid belt and these distant regions are more than just curiosities. They are key to understanding the history and evolution of our solar system. Each rock and icy body holds a piece of the puzzle, revealing the dynamic and ever-changing nature of our cosmic home. As we continue to explore and uncover the secrets of these far-flung regions, we gain a deeper appreciation for the complexity and beauty of our solar system. Stay curious and keep exploring. Welcome to Chapter 6, the future of our solar system. As we journey through the vast expanse of space and time, we shift our gaze from the past to what lies ahead. Our solar system, ever dynamic and evolving, faces a future shaped by the aging of our central star, the Sun. Currently, the Sun is in the middle of its life cycle, comfortably burning hydrogen into helium in a process that powers its radiant glow. But this phase won't last forever. In about 5 billion years, the Sun will exhaust its hydrogen fuel and begin its transformation into a red giant. During this dramatic phase, the Sun will expand, potentially engulfing the inner planets, including Mercury, Venus, and possibly even Earth. As the Sun grows larger, it will also lose mass, causing gravitational changes that will affect the orbits of the remaining planets. Mars, the asteroid belt, and the outer planets will drift further away from the expanding star, altering the balance of our solar system. The red giant phase will be both a time of destruction and creation. While the inner planets may be consumed, the outer solar system could experience a renaissance. The increased heat from the Sun might warm the icy moons of Jupiter and Saturn, potentially creating habitable conditions where life could thrive. After shedding its outer layers to form a beautiful planetary nebula, the Sun will shrink into a white dwarf, a dense, cooling remnant about the size of Earth. This white dwarf will continue to glow faintly, gradually fading over billions of years as it releases its remaining heat. The future of our solar system is a story of change and transformation. The planets, moons, and other celestial bodies will continue to evolve, influenced by the Sun's aging process. New worlds may emerge while others may fade away, all under the watchful gaze of the Sun's final form. As we contemplate the future, we are reminded of the resilience and adaptability of the cosmos. The solar system has undergone countless changes since its formation, and it will continue to evolve long after the Sun's light has dimmed. By studying these future possibilities, we gain a deeper understanding of the forces that shape our universe and our place within it. Stay curious and keep exploring.